start the AGU this week, I believe, so we're missing a few notable faces. But wherever you guys are, I hope you're having loads of fun at AGU. Let's see. And then the other notable announcement is that there's no meeting next week, or December 28th, or January 4th. So I'll have a bit of
Hooray.
all right.
All right, I'll put the URL to the Google Doc about Gareth Perry's Eclipse Irregulars here, but I'm not, you may have to send me a request to have it shared. I don't know if this will work.
That is totally fair. I just figured it would be okay if it hung out in the announcements gallery. Any other announcements?
I have a question.
Sure.
Concerning Grape 1, is there a current node list that relates node number to Grid Square? John?
Grid Square. Yes, I have that list, but I have not published it for obvious reasons.
What are those obvious reasons?
Name, address, phone number, all the personal information. So that's why.
Don't need all that. There is one.
Trying to think if I could somehow. No, there's one. If I did some manipulation, I can. What are you looking for? A call sign in a node grid square or what?
No, just the node number and the grid square so that I can access the data files.
I could probably create that from the Excel and export that. If you send me an email, so I have your email address, I'll send it back to you.
Okay.
Are we talking FL Digi or DRF?
FL Digi.
FL Digi, okay. Yeah, I do not have the DRF.
Okay, I'll send you an email right now.
Thank you.
Thank you.
Good morning.
Good morning. How's AGU treating you?
It's going fine. I looked at my schedule. I'm like, I can actually make this telecon this morning. So here I am.
Hey, Nathaniel.
How are you?
Bright-eyed and bushy-tailed.
That's right. 7 a.m.
Nice and early out there.
That's right. How are things going for all of you?
Quite well. Thank you.
Excellent. Well, I'll let you just keep going on as usual. But things are going well. I'm going to be giving a talk that includes the Grape data this afternoon. So it's in a union session. And everyone who's here, they say hello. Bill Engelke's here. We spent the day with Rob Robinette yesterday. We went out to KPH. Christina Collins is here. Yeah, so we're having a good time.
Yeah, relay a note or a message to Bill Engelke. I ran his tests on his DRF, and I'm going to hopefully have them posted in this meeting minutes, but there's some interesting things going on that I did not expect.
Okay, sounds good.
Let's see. All right, no announcements, and we won't talk about them until after the Grape 2 updates, but does anyone have anything that they know they want to talk about today, or we want to reserve time for?
I've got digital RF testing results.
Okay.
And I'll say a word about the long path experiment, the CHU experiment.
Okay. In which case, I think we can get started with the Grape 2 update.
Been a very productive week. Saturday, I did a 12-hour marathon, and I fixed the last 5 problems on the logic controller board. I got the board pushed out to the manufacturer, and they're in the final processes now of scoring it, and I'm going to ship it. So I probably will see them next week. Also went through the entire parts list, and the parts I did not have, I put on order with DigiKey, which has been shipped. So that is done. I got the parts list and the new board out to the board manufacturer for a quote, and they have not gotten back to me yet, which I'm a little disappointed on. Today, the RF deck boards are supposed to be finished at the manufacturer. They're supposed to contact me when I come go down to Hudson and pick them up. They're about a 15-minute drive from my house at home, which would be an hour and 15 minutes from here. Anyway, hopefully I'll see those boards by the weekend. Let's see, what else did I do? Parts list, ordered the parts. Oh, I also sorted what I had into a box and labeled them and categorized them on a parts list and noted what I had for them to be able to take them in and inventory them. So that took a couple hours for all the parts. And interestingly enough, that board has 212 components as compared to the RF deck, which had 228 components. So not a hand assembly part for the faint of heart.
Okay. Nice
And
stretch.
I think, yeah, Sunday I kind of collapsed. That's it. I think that's it for that's for the hardware. We've been making more progress on firmware. I updated the very simple status screen to actually show the amplitudes that I'd forgotten, and maybe, I don't know if Kung's on this, we can show that. Bill's been working on incorporating the testing, and he's also working on some other aspects of the software, which I will let him update as well. But other than that, I think that's it for me. Back to Net.
All right. Should be the next question. Is Kung on this call?
I am.
Are you guys also in finals week?
Yes, I am. Yes, I'm in the middle of finals week, though. It's a bit stressful. But
That's
yeah,
fair.
I did implemented the peak status display that John mentioned.
Would you like to share your screen?
Yes, please. Status,
Yeah, the emphasis on creating this screen was to keep it simple, so you could look at it in a glance and know what was going on. It wasn't overly, complicated or messy. I wanted to keep it very clean.
yeah,
And
this section wasn't here last time
right.
that I showed this display.
And
So
the
there were,
maximum
yeah,
24 hours actually is a sliding 24-hour window instead of being on the UTC date. I figured that'd be better.
Yeah, it's just some small bugs that we gotta iron out. Like one small bug that I'm running into is if there's any error in decoding the data being sent from the Pico, this monitor would crash, which is
Ooh.
not a good idea. So if it's fair to decode, it would just skip that and go to the next one instead of crashing. So this monitor gonna stay up regardless of the errors it's running into.
Yeah, this doesn't have the updates I done version 6 of the screen because you don't have 2 decimal places on the firmware version, and the magnetometer fields aren't the right size. But this is really close.
Where it states radios 1, 2, and 3, like WWV10. Is that, can we differentiate between WWV and WWVH, or where does that field
No,
come from?
no, we cannot.
Okay.
that's back to the net.
Nice.
Yeah,
Any
I
other
forgot
questions?
about Kung's finals, so he's a busy man.
Almost there. Just 2 more.
I don't miss those days at all.
Didn't you just have a 5-hour working binge on Saturday?
Well,
Feels like you're in finals too.
yeah,
I'm
well,
gonna say some of us get
permanent.
to administer pain today to some of our students, so
Uh,
Okay.
Bill, do you have any updates?
Yeah, I finished the RF deck automation code for testing the RF deck, and I'll be checking that in today. Um, and I sent some raw data to David Kazdan, so he could look at it at the frequency estimator and tweak it to improve our readings on that. And I've been communicating with David Witten about the magnetometer integration. We might like to get on with you, John, and discuss the timing accuracy of the timestamp requirements for that, and maybe Nathaniel and whoever else has input into that, because we're we don't really understand the physical phenomenon that are going on to the extent that we could make a decision on how accurate that timestamp needs to be.
I can make a comment there.
Okay.
The comment is, how accurate can you give us? because
yeah.
this is kind of where the cutting edge research is. We don't really know exactly what all the small scale features are, and most of the space physics research right now is down to if you're giving us accuracy that lets us get 3 millihertz accuracy in the end product, that we are doing really, really good science, and that's what we're expecting. If you're able to give us something that's much better than 3 millihertz accuracy, that gives us the potential to look for things we don't know are there.
Okay.
So
we can
millihertz or nanoteslas or microteslas?
For the magnetometer, definitely nanoteslas. If
okay.
Ideally,
we are reporting it to a nanotesla.
Okay. Yeah, I think the my understanding was with the magnetometer was that it was good for a resolution down to like 13 nanoteslas or somewhere around there.
Yeah, he had in the paper that Dave Witten had written, I believe there was a statement about it had a resolution down into the hundreds of picoteslas.
Okay.
But with the 300 sample resolution, it's in the tens of nanoteslas. And I want to say the normal vector for that, each axis is like I think the normal magnetic field here is like 60 microteslas.
Mm-hmm.
So
I can tell you all the science for magnetometers for space physics is down at the nanotesla level.
Okay. Well, we are reporting it to 1 nanotesla. Okay. We can take it farther than that if you want it. I don't know if it's noise digits or not, but we certainly can extend it out.
The question is, if you gave us more, is that meaningful?
That's exactly why I'm asking. Is it just noise or is it a meaningful number? So I'm not sure. I mean, Jules, I think, was the expert on that. And since he's passed away, I'm not quite sure who to talk to. I guess Homan would be the person.
Yeah, Homan. I would think so. I think my philosophy for the moment. So here's the benefit and the danger. The one philosophy says, please give me everything you have, because in post-processing, we can look at it and we can make some estimates. Is it noise or is it not noise? And I think that is a very fine way to do it, so long as we make it very clear that we're not guaranteeing that accuracy, and this is the accuracy we're guaranteeing. The other philosophy is don't give them anything more than we know is accurate, and that way people don't do dangerous things with the data.
Yeah, being that the resolution I thought was the 13 number comes to mind, which is why I was going to report it as 1, which gives you another order of magnitude below what it was. And I felt pretty comfortable with that. But I'll review it with him and see what he recommends.
That sounds good.
And we're reporting it once a second, and I've been running mine now for 2 months in the backyard. I mean, I'm not collecting data, I'm just running the engine.
Yeah.
And it's reporting a number once a second. So I'm guessing the 300 average is able to do that within the 1 second epoch.
Mm.
So that's what we're going to be sucking in. But
the other question I was posing, though, was the timestamp on the magnetometer data.
Mm.
The timestamp on the spectrum data is determined by the pulse per second from the U-Blocks GPS chip. So that's pretty darn accurate.
Yeah, I don't see anything. Most scientific grade magnetometer data these days is being reported once a second or maybe 10 times a second.
Yeah.
So I don't see you needing to do anything more than that. And then you also have to consider, like, if you're again, I think there's some averaging going on there. So if you're averaging a certain amount of time,
it actually samples like 100 times per sample. But the getting back to the question I was trying to pose was just that, do you want that like synchronized on the pulse per second, or can it be a few milliseconds late, because we're running into a software issue with getting a pulse per second on both the magnetometer and the spectrum data. Did we decide not to use the 1 PPS because you were not going to incorporate it inside of your main collection algorithm? And are you still planning on running that outside the algorithm? Well, ideally, we would run it outside the algorithm and then communicate from the magnetometer reader, which is a separate program, through a name pipe to the data controller. And that introduces the latency. I'm just concerned that latency may be too great. There's already a latency on the I2C read, because I think that's a 400 kilohertz reading, and if you're doing 100 of them, well, I think the averaging is happening in the magnetometer. Okay, so you're doing one read. So you're doing one read. But still, that latency plus the latency on the name pipe from the magnetometer process to it's starting to sound to me like we want to include just the read algorithm inside your program, because it's really not going to change. I mean, the impetus to put it outside is to allow it to be updated, but it hasn't changed in 4 years. Yeah, I'm thinking that way too, but I think we want to get Dave Wooden on the line, on the call this afternoon, maybe. Because I think just his subroutine to do the reads, and then that would be triggered off the 1 PPS. That was my intent. Right. Because when the 1 PPS hits, you go out and read it, and you synchronize with the timestamp of the exactly. RF data.
I don't think anyone is doing any magnetometer science with a time resolution shorter than 0.1 seconds. Oh, okay. And even that would be unusual. So I mean, I don't know that, if we started doing, like, what you're talking about, like milliseconds here that you're trying to deal with. Yeah. I mean, if you if you did anything with milliseconds and we tried to publish anything that came down to milliseconds, we'd have to really, be very, very careful in our analysis. That, and I'm not sure that using a large distributed network of low cost magnetometers would be the appropriate instrument to be doing that level of science.
Gotcha.
Can I ask a question?
Yes.
By the way, it was good to see you, Nathaniel. With the magnetometers, like, what's the science objective?
So first of all, Steve is here with me at AGU, so I saw him in person yesterday. The science objective is well, primarily, since these are mostly being distributed in the mid-latitude section, to look for, you know, shorter time scale mid-latitude magnetospheric phenomena.
So you're talking like VLF waves and stuff like that, or ULF waves?
Yeah, ULF waves.
Okay. I mean,
yeah,
I don't think you need to worry as much then about having extremely high time resolution. I mean, I know the magnetometers in Alaska that look at electrojet stuff. I mean, like Don, I think they do sample one every 10 seconds, but like, or no. I mean, one, like, it is 10 hertz data, but I mean, like, for all practical purposes, if you're looking at electrojet, I mean, 1 second is like more than sufficient.
Yeah, that's what I was saying.
Okay.
So everything that you are quibbling about in terms of, like, you know, do we get things down to 10 to, you know, get accuracy of the grape to be better than, you know, 1 millihertz? Do we get the time resolution on the magnetometer better than, you know, 1 second? You know, that's like super bleeding edge science cases that we don't really have good justification for having to go down to that level.
Okay.
The reason I'm saying, if you can give it to me, like, if you're able to give it to me without a lot of work, that's fantastic, because maybe we will see something we don't know about. But if you can't do that, I wouldn't stress too much about it.
Okay.
Certainly micro Teslas is not good for magnetometers. You definitely want to be, I'd say, at minimum in the 10 nanotesla resolution range.
Yeah, we're measuring to 1 nanotesla.
That's much better.
We'll get that. But
Yeah.
just a question about the time resolution.
Well, the time resolution is kind of a double-edged sword, because we were able to sync to the 1 PPS, which is highly accurate, but it's taking 300 samples as an average, so that's sort of slurring things out over that time period. So it's really, it is, but it isn't.
Yeah.
I'm saying you don't really have to stress about this too much.
Yeah.
Okay.
I think what Dave Witten has written and has been running will be fine with his collection routine.
Yeah.
Since we gives the number once a second, and the numbers look, I mean, I don't know what a good number looks like for a nanotesla for a magnetometer, but we should be able to pull that.
I don't see it changing that much, but
no,
several seconds, but I didn't know about the rate of change either. So
I mean, I think my opinion is, I think the more important problem, and I haven't been part of these discussions, but I mean, the more important problem is making sure you have sufficient, resolution that you can resolve stuff.
Right.
You can resolve features. So, I mean, measuring 60 nanotesla, but if it goes by, 10,000 nanotesla up or down isn't super helpful. I mean, but if you can get down to, nanoteslas, or you feel like you have nanotesla precision or whatever, I mean, then that's much more helpful in terms of tracking changes. That's just my 2 cents.
And is it a valid assumption that the total vector normally for our latitude is in the 60 microtesla range? Does that make sense?
Yeah, that's about right.
Okay,
I mean, at high latitudes, I always use like 50. I use half a Gauss. So, I mean, half a Gauss is 40 or 50 microteslas or whatever.
Okay, that's what
right.
I wanted to know. Will we ever see numbers above 100?
So generally in the equatorial region, it's going to be around 90.
Okay.
90,000 nanoteslas. And at the poles, it's going to be, maybe like half that, 45.
Okay.
30 nanoteslas.
So reporting 3
digits.
What's that?
I always use 50 at poker, and that's pretty good.
Yeah. And he's using 50 at Poker Flat, Alaska, but it can go lower as you get closer to the poles.
Oh, I thought he was playing cards. Oh, never mind. Okay, so I'm just trying to get a quick rule of thumb of what numbers make sense, because I have no inherent understanding of what a normal reading would be.
Yeah.
So I'll just make a comment that you could put in there are like online calculators that, I mean, it's like you put in your longitude and latitude. Like if you just look up geomagnetic field and NOAA, I know that they have these, and that will tell you at your particular location what the expected magnetic field is based on IGRF, which is
actually, I have used that for the
reference.
magnetic declination calculations for my antenna. So yeah, I'm familiar with that. Okay, thank you. Back to net.
Well, the thing to remember, a Tesla is 10 to the 4th Gauss. And the nominal Earth's magnetic field is about half a Gauss. So it would be 5 times 10 to the minus 5th Tesla.
Just 50 microteslas, which makes sense.
Right.
Cool. So we'll talk about that this afternoon, Bill.
Okay.
Back to net.
All right. Anything else on Grape 2 updates? All right. Sure, it's a little bit. For open projects, did anybody get any more information or testing done for the amplitude drop-off issues?
That's
Well,
what I have.
Correspondence with WWV's engineer said he doesn't think it's them.
Right, we did have that a few weeks ago, I believe.
Yes.
I'm looking at that across the country, which is why I want that node list of all the reporting nodes, or all the registered nodes, not all of which are reporting. But I do see it. Not everyone sees it, but I do see it, and I think it might be a traveling ionospheric disturbance. You can see it geographically different, but present on some mornings. On some other mornings, you don't see it at all. But not everyone sees it. For instance, this morning, the New England group did not see one, but British Columbia saw one, and a big wide one. And I think, I forget the other ones that saw it, but it was widespread.
So it's definitely where not everyone sees it at the same time.
I'm sorry?
It's definitely a case where not everyone sees it at the same time.
And but not everyone sees it for the same duration.
So I think the first thing we need to figure out, which I think you are well on your way to doing, and you already know, is we have to figure out whether it's a natural thing or if it's a system instrument thing.
Yeah.
My personal opinion right now is that I think I'm more suspicious that it is an instrumental issue and not a natural issue. And the reason is that it happens, very suddenly. I mean, it's like you're going along for hours, everything looks fine, then all of a sudden there's a dramatic drop off.
Right.
And that is on for a number of hours, and then it's a dramatic kind of back to normal. And I don't generally, what I've seen in nature is it doesn't quite work like that. So
I can agree to that. Not that I've seen as much nature as you have, but when somebody in the New England group sees it, we all see it, and and it's all kind of the same for the same duration. And others in other parts of the country see a similar, but not at the same time or the same duration, but overlapping. And I tend to be of the opinion that it's some kind of natural effect of attenuation
I
somewhere.
should be able to shed some light on that with my digital RF testing that I'm coming up with here.
Okay,
Good.
I'll say one more comment. A third option is it's a combination of the two.
Yeah.
Maybe some sudden impulsive event like a solar flare or an electromagnetic current overhead that you could detect with the magnetometer. And so it's an impulsive thing that triggers a particular state in our instrument that stays that way for a certain amount of time. And so that initial like triggering causes it to go into that case. But if the instrument were really doing what we wanted it to do, it wouldn't look so impulsive.
Which instrument do you refer to? The Grape itself or the the Grape itself?
Right. So so this is totally hypothetical, but let's say that the way we're putting it into this cheap, inexpensive sound card, we're using that as our A to D. Is there some possibility that the A to D gets overloaded and then that flips it, into some other regime inside there where it starts trying to compensate for the overload and spits out lower values?
I can answer that question.
Go ahead, John.
I can answer that question. I've got.
Why don't we go on
to it.
I'm very interested to hear what John has to say. So,
also, Bob has done some testing and found no overload.
Okay.
But go ahead, John.
Do you want me to start with my presentation, Rachel?
Go ahead.
Yeah, I'm going to do a screen share here. Okay, so last night, my little half-hour project to do this testing turned into about 4.5 hours. This was my setup. I had a benchtop attenuator that gave me from 0 to 80 dB attenuation in 1 dB steps. And then I added this little module here, which, come on.
Zoom.
Yeah, it's not letting me grab. There we go. Now I can get control. That little module looks like that. This is a 1K ohm resistor. This is the output for my Hewlett-Packard Z3801 GPS discipline double oven, blah, 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 10 megahertz output standard. It outputs a sine wave at 3.3 volts peak to peak. So that's what's sitting on this node right here. Goes through a 1K, and then there's a 50 ohm here into the front end of the Grape going here.
Yeah.
So this is the maximum signal I can slam into this is actually the output of the Grape into the sound card. And you can see here, it's 4.24 volts peak to peak. Now, the sound card is rated for 1 volt RMS, which is 1.414 volts peak or 2.8 volts peak to peak. So this is slamming the living daylights out of the input of the sound card.
Right.
So I cut it, so I put it in, was playing around, and decided maybe let's cut it back and start at a lower level. So this is a 200 millivolt peak or 400 millivolt peak to peak signal, a little bit of noise on it, which generates this on the spectrum graph or his little plot.
Yeah.
Which I let it run for an hour, and that was this segment right here.
Yeah.
So it was nice and clean. It looked okay. So then I moved up to a amplitude here of, I'm sorry, this is another shot of the 400 millivolt peak to peak that ran for 90 minutes. So then I kicked it up to 1.54 volts peak to peak, or about 750 millivolts, which would be about what you would normally get for a signal. And that you can see bump this up a little bit and kick this amplitude up a little higher. And I'll let that run for 90 minutes. And I thought at first it was this, but I'm really thinking it's this, because I think Bill's graph updates and slides up.
I think you're right.
That's correct.
So that's looking what it did for for that time. Let's see, can I, yes, I can. Here we go. So a little bit of splattering on his resolution of the spectrum. So then I kicked it up to the 4.4 or 4,400 millivolts peak to peak and let it run overnight. That's what I got. So the spectrum was obviously splattering, but the amplitude did not drop with the horrific overload at the front end.
Right, and we did not see it drop out.
And it did not drop out. No, it just, as you would expect, it's giving you, there's a nice strong line there and you get stuff splattered all over the place.
It's overload.
So what I did this morning is I flipped it back to the 750 millivolt peak, and I'm letting it run all day, and I'll have another picture that I will be able to probably get tonight. But what I'm seeing is, you can see this here, really, you can see the spectral splatter. But I'm not sure this spectrum here makes any sense, because this says this is 600 hertz here. So this would be 200, that'd be 100, that'd be 50. I thought he was taking a plus or minus 5 hertz swath, which means this is really.
I don't know that you can trust the axes on this graph.
Yeah, it didn't make any sense to me, because this is too narrow. So I think he just have them there. They're a number.
Yes.
But it doesn't have anything related, because I know if you look at the timestamp here, this makes no sense to me either.
Yeah, I know this was put together very quickly just to give us some sort of visual display, but I don't believe those numbers have any basis in reality.
I wish somebody would fix it.
Well, when we get a chance to, we will.
Yes,
Yeah,
we will fix it.
So, John, probably what
John?
you're seeing there is the phase noise of your generator that's been raised up considerably. And I know the 602, all it's going to do is clip. It's not going to, unless you had some odd rectification going on, which generally it doesn't.
No.
It's just going to clip. It's not going to block it.
Have we,
John? Can I ask you a question, John?
I guess so.
What this was input to the Grape or input to the sound card?
This was, I input the signal into the Grape, but but the 4.4 volts was the output from the sound card into the output of the Grape.
I did essentially the same experiment a week or so ago, but I had much less time to dedicate to it. And I had the signal generator I'm using was pretty unstable. It was a 60606.
Yeah, well, the RF signal is the 10 megahertz that's attenuated, and it's a sine wave. It's not the square wave like the Leo Bodnar, so I'm not getting harmonics from that.
I was putting in sine wave data. I put in data from 100 minus 110 dBm to minus 30 dBm in 10 dB steps. And
this is actually looking at the input to the sound card, which is really what I was after, because that's what we were worried about. Because I'm pretty sure that the 612 just clips it. It doesn't do anything weird. It's a ring multiplier. So
yeah, I'll point out that what you may be looking for is not on frequency interference, but off frequency.
Yeah.
Which, because if it clips it and you get the capture effect like in an FM receiver, it would knock out your 10 megahertz if something is off frequency and you wouldn't be seeing it in your passband.
That's a good point.
Because what I'm showing here, this top part was the real live spectrum response from 10 megahertz WW before I disconnected it. This was I believe was the 400 millivolts peak to peak signal going in. And then this was me slamming the thing.
Yeah. Well,
Question.
Go ahead, Dave, or Nathaniel.
Yeah. Have we done a systematic study to see if we have a grape that's running both FLDigi on one grape and a parallel grape running? Bob is raising his hand. All right, Bob, let's hear.
I have that set up as well.
I have a setup. I have a setup here, and I have a setup in North Carolina where both the audio from the sound card goes to both an FLDigi system and the DRF system.
As do I.
And we observe it on both. Plus, this phenomenon is happening both in the FLDigi systems and the DRF systems.
But I can definitely say that an input overload to the sound card ADD does not cause it to diminish its output.
I've got to agree with John. My data said exactly the same thing. I was grossly overloading. There was stuff showing up everywhere on the waterfall and on the spectrum display. I was looking at things at FLDigi with the spectrum scope. Saw all kinds of stuff, but I never saw a dropout.
Yeah, this definitely, I'm putting what looks like a square wave by the sound card clipping it, and this is what you get. And this is driven, 1.4 is the peak max, and I'm putting in 2.3. So I'm really slamming that thing hard. And it's not dropping out.
But if we go back, so Bob, you are saying that when you run the systems in parallel, every time you see a drop off in the DRF system, you also see a corresponding drop off in the FLDigi system. And every time it comes back up there, you see the same pattern with both systems.
Yes.
Okay. Well, with that, so I mean, that implies to me that there's something that doesn't have to do with the data with the software.
You mean how FLDigi is handling it? Or well, they're both handling it similarly.
Doing it. It's not FLDigi or DRF. It has to be something with the hardware chain.
Or can it be something with the ionosphere?
I
don't see the fingerprint of it being the hardware chain because we're not seeing the attenuation drop when we overload it.
If you look at
that to me rules it out. It's not. I think this is a real phenomenon.
Yeah, if you look at the Doppler data as at the time the thing is dropped out, the Doppler data continues on whatever path it was on.
What I can tell you is, if we can blame it on the ionosphere, someone has a very nice paper that they can get published.
That's what I'm working on, Nathaniel. Yes.
Nathaniel?
Yes.
I since I've been playing around with this grape stuff, I have always been more intrigued with looking at the amplitude variations rather than the Doppler.
Exactly.
And I have observed this for some time. I mean, going way back, and I just thought in my, you guys are the experts. I'm not, but to me it was always, well, the band went out. I certainly have seen my DX station dropping the noise just as quick.
Yeah.
That's what this is.
So it's such wide range. And like I say, I've looked for it and I haven't seen it on the hardware.
Yeah.
And how we've got hardware synchronized across this country seems.
Yeah. So I think this is all really good, but I think this is really good. So I think the thing to do, there are two tracks then. I think one, we really do have to absolutely continue making sure that there's no hardware issue or we don't have something like, what Dave McGaw said maybe it's like out of band interference that's causing something to wipe out. Do you have some third party transmitter on a nearby frequency that's yeah?
I put up a narrow bandpass filter in front of the 10 megahertz here because I have lots of noisy neighbors. I jokingly call the millstone site in my backyard.
Yeah.
But I have seen this phenomenon of blocking. But it's blocking on such a large geographic scale.
Yeah. May I share my screen, please?
You certainly can.
Yeah.
Thank you. This is last night's plot from Bill Blackwell for not everybody, but just these guys. And you see these long dropouts here.
Yeah.
None of these are the New England guys, but one of these is Ladysmith, British Columbia. That's this purple one. This one down here is I think that's Virginia. This one is Indiana. But if you look at the Doppler plot, it's Ladysmith kind of goes wanky, but they're all they're kind of overlapping. Now I don't have right here. Let me just look. Where else can I find this?
If they all dropped at the same time, I'd say WWV's dropping out.
Right.
Because the timing is a little bit different. That
they're in different, I mean, the Earth is rotating 15 degrees an hour here. And something's happening up there, or in the medium from the Earth to the atmosphere, to the ionosphere, or as the refraction occurs, there's some attenuation somehow.
It's got to be alien spacecraft. That's all it could be.
Do we have West Coast grapes we can check?
Can I hold on? Hey, may I jump in here for a minute? Okay.
The blue trace is 15 megahertz.
I really like the idea of saying maybe it's some ionospheric phenomena or some geomagnetic phenomena. I think that's a good, we've done some testing on our hardware in the processing chain. Gary made a nice point in the messaging chat window that says we need independent verification. Now, one of the things that we have access to are data from other professional instrumentations that are not grapes.
That's right, correlation. Yeah.
In many different ways. And if we can show similar timing in those other instruments or those other indices, then we can show independently there's something going on that's not WWV. Right. So I think that's the next
thing. Or the grape.
Yeah. Well, Dave is trying to say something.
Something in between.
Well, it was kind of interesting when we were doing the 2019 100th anniversary. We were operating on 30 meters, and Matt Deutsch actually dropped the power of WWV's 10 megahertz broadcast for a little while to see if we were able to hear people better, if he could drop the noise floor for us a little bit, being right next to the station. But maybe a suggestion would be to talk to Matt Deutsch and actually do a planned drop of the power of WWV and see, you could actually run a planned experiment and see what happens so that you can eliminate that possibility.
This is like asking that the sun be dimmed. This is like an eclipse.
I think
they'll do it for you. I mean, you could have them drop the power a little bit. I don't think it would really do anything, that they're not allowed to do. So they have to change transmitters from time to time because
they drop from 15 kilowatts down to, I think it's 5 for the temporary transmitter.
Well, actually,
they're doing maintenance.
It's only 10 dB.
Only 10 dB.
Their power plan permits 1 full day per year off the air. So, you can request a bit of that time.
Actually, I think this is a really good idea. Because if you can ask Matt to say, all right, what's the lowest power you can drop it to? Let's do a controlled experiment and see what happens. And the reason I think this is a good idea is because, again, if we go to publish something like this, the reviewers are going to ask, is it the same questions they're asking? Is it this? Is it that? And if we do the drop, we can sit here and be like, oh, it's only 10 dB or whatever. But if we actually go do the experiment and then actually record it, it's going to give us a lot of good ammunition to be like, oh no, this is, it's not this thing. Even if we don't see anything there, that's really good data. And if we do see something there, that helps us to as well. So I think it's an excellent idea.
We have a station in Florida, Bill's, and we've seen his signal not drop out when we have a major dropout.
Right.
And we're talking 30 dB or more here at times. And that's more than 5 kW to 50 kW.
Okay.
That's like what?
Have you cross-correlated 10 megahertz and 15 megahertz, for instance, or 5?
We've seen dropouts similar, if I remember right. If I remember the data, I think we've seen effects at both 5 and 15 on occasions.
This is yesterday's data from the New England Grape Group.
Oh.
And I filtered it differently. I filtered it instead of at, what is it, hertz? That's in the plot routine, 10 minutes. There should be 20-second averaging. I'm filtering this at 30-minute averaging just to get rid of all those little bumps, because I'm looking at the big bumps. And this is the Doppler shift for that day. And this is, come on, I don't want all of them at once. This is filtering at 20 seconds. This is the normal 20-second, what you'd see in Bill's plot and the Doppler. This is 30 minutes. What I'm doing is spreading it out.
Mm-hmm.
And this is 60 minutes, which is a bit much worth of too much. But the point is, it's still kind of there. Just by the way, let me move on here.
I'm interested that the Doppler shift doesn't show anything on those transitions.
It doesn't.
Who is the person that said they talked to the WW here and they said that there were not any power drop-offs during these times?
I have heard that, yes.
Who is the person that actually talked to them?
88Y.
David did.
Yes.
David, yes, you actually talked to WWV and asked, were there drop-offs there?
Yes.
Are they able to, instead of just giving you a yes or no answer, are they actually able to give you a log of when they did the drop, of when what the power out is as a function of time?
I'm sure they can. I didn't ask that, but yeah, that's Matt and his technician's job.
Could you ask and see if we can get a log of WWV power out as a function of frequency and time?
Well, ask.
Thank you. Because then we don't have to do the controlled experiment because we'll already have all that information.
Well, then we can look for correlations.
Yeah, or you might. Another question I will ask is, can they keep us posted when they have scheduled maintenance?
Right.
True.
Because we can take advantage of that.
Yes, we can take advantage of that. But if they already have a log of power out as a function of time, and they can just give us an ASCII file with that information, I mean, that would be like gold.
That would. This plot is my signal from the day before yesterday with no filter.
George?
And this is with the
other thing.
We need to see if we can find a case where during this period the signal doesn't drop.
Oh, sure, like today. Our signal this morning was didn't drop, but it did in British Columbia and in Virginia and in someplace else. Where was that?
We also have a control station, don't we?
Yeah, WODAS has it.
Right. Yeah.
Dave Schwartz.
This is yesterday.
Yeah. Right. Dave Schwartz, you're a control station, aren't you?
Yep.
Yeah, you're just listening to it all of the time. Maybe
he has no choice.
His fillings hear it all the time.
Do you want to see my 10 megahertz plots? See if they compare. I have them right
Yes.
here. Okay. Do I have screen share?
Wait. Hold on, I wasn't done. So Dave, W0DAS, you are within essentially line of sight or ground wave of WWV.
Right.
Right. So maybe for all of these plots, we should also be plotting W0DAS's line and make it like thick or something. And that's our control line.
Yeah, because it's an actual receive signal with the same receivers.
Bill can probably do that. Can you do it, Bill?
I can do that. Dave,
Okay.
what's your grid square and node number?
The node number is 16. So
Okay.
N 00000016.
And grid
Grid
square?
square is DN 70 KN.
Got it. Thanks.
Hey, somebody use my node numbers.
Of course.
Okay, I'm gonna, guys, I'm gonna have to get off pretty soon. So if you want to see my graphs, let's do it.
Sure.
Okay, here is yesterday UTC.
Look at that.
I'll go back a week. You said a little louder. Yeah, there you go.
Huh.
Another. Any day in particular you want to see?
No, but it's definitely got a fingerprint of something going on there.
Yeah, and I think they all match the ones that everybody else has.
Yeah. Who would have thought the amplitude data would have been important? There it is again.
Yeah, it changes from day to day. I've been following CHU 7 megahertz, and I've been amazed how much variation in signal strength there is by time, by day. And here's some abrupt dropouts. So anyway, I think it's not a big mystery.
I'll just point out a couple nights ago here in New Hampshire, I was only getting 5 megahertz and everything else had dropped out.
Yeah, sun's been pretty active this month.
I've been surprised that CHU 7.85 is generally not good here at night. I would have thought that 40 meters in general was a nighttime band, but that's not what I get here.
Yeah, that's interesting. My most consistent is 785.
Yeah, and mine is gone almost every night.
Yeah, so is mine.
I think I think looking at this is all really interesting. I think adding W0DAS's line to the plots as a standard control is a really good idea, especially because we have that data right now. It's right next to the transmitter, and I think that's a good control we can do right now. I think
it's also the same receive chain.
Yes.
Analog wise, which is huge.
What?
Yes. That's really
well,
good.
It's not exactly the same.
Well, okay, but I think it's a good start. So I do think it's a really good idea for David Kasdan 88Y to ask to see if we can get the power output logs. I think that's the worst they can say is no. The next best thing they can say is we don't have them now, but we can start recording them and giving them to you in the future. And the best thing they can say is, oh yeah, sure, here's a file. And then the third thing I think we should do is I think it would be useful to I think it seems like we're able to cluster the grapes. So like the New England group has said that we see this phenomena all in New England, but not necessarily in other places. So it'd be interesting to see if we can figure out what the scale size of this disturbance is. So like how far do you have to go away from New England before it's different? And then if you go to a different place, is it like all the stations within 100-mile or 300-mile radius that see the same thing? So I think that would be a good thing to figure out. And I think another thing that would be useful, which, maybe I think I can help with, is we should systematically learn about the other instruments and data that's available to us. So for instance, there's a network of ionosondes across the country. There's a network of super darn radars across the country. There's a network of GPS TEC receivers across the country. There's a network of what do you call it? Magnetometers across the country. So we have access or can get access to all of that data. And typically those are, they're more vetted instruments that have a longer heritage of understanding, and that they don't rely on WWV. So if we're able to look at some of the data from those instruments and show, what things that match, we might be able to help identify a cause and prove that this is real and not just our instrument.
There are also independent receivers like the Kiwi network.
Right.
I'll make one more mention before I need to leave. For the CHU Along Path experiment, the Radio Association of Canada has agreed to provide a control station in Ottawa. So roughly the equivalent of what Dave is doing. And yes, I think it's important. I also contacted CHU's chief engineers. They are not planning any maintenance for Eclipse Day. So they know we're doing this.
That's great.
Okay, 73 all.
73, David. And yeah, David McGaw has a good point too. There's independent receivers too. So like Rob Robinette, he is here working on he's here at AGU, and he's working on making a completely independent hardware chain that can make similar Grape type measurements using the RX888 and his Kiwi SDRs. So using a completely different set of hardware, we can see if we can see the same thing. So we have a very nice multi-pronged approach.
I'll just say that we looked at one point when we had a New England dropout, we looked at the Millstone Hill ionosonde, Digisonde, and the maximum usable frequency had dropped to a megahertz on the Digisonde. Now, the trouble is it's not in our path because it's right here.
Right.
But that kind of correlated with the fact that we had a dropout.
Yeah, but there are a handful of ionosondes running throughout the country. So there is one or two in Boulder we can look at as well. I think there might be one in Michigan. So there's a few. We can look at a few different ionosondes. And yeah, if the ionosonde, that's probably the easiest place to look next. If we look at the ionosonde data for there's I think at least 4 ionosonde stations I think are worth looking at. If they all show a sudden drop off in MUF, that's a great answer. That very strongly supports that it's ionospheric and not us.
I'm gonna continue some testing. I'm gonna try. I'm really motivated right now to try and get a CHU station on here.
That sounds great. And if anyone,
all I've got to do is clobber it together. I've got the LO, I've got the Grape, and I've got the Pi. So. And
Nathaniel, I do have FL Digi running on 5, 10, and 15 continuously at my QTH, as well as digital RF on 10, all coming from exactly the same RF source. So great. That's all correlated and it's the same signal. So that should be helpful. And I can add the RX888 at a later date.
Excellent. Here's the website for the ionosonde data. gyro.uml.edu. So you have, through that website, you have access to plots from ionosondes all over the world, and you should be able, and I do have written up, if you want to, I do have made up already a script that will plot the ionosonde parameters as a function of time. And if I know we're at the end of our time here, but if anyone wants, I can stay on for a little bit and show you how to use that. And then that'll actually get you the numbers for like MUF or something like that for any ionosonde you want.
I might be interested in that.
Okay. I think that sounds good. I think, you know, if we can actually explain this, I think this would make a really good paper. And I think it would be really good for a couple of reasons. One, I think it will really help to explain, you know, show that our instrument is seeing something interesting and useful, and help explain away a potential someone going like, oh, what's that? That doesn't look right. So I think there's a lot of value in doing this. Back to you, Rachel.
No arguments here. I think that's it for everything we had. Are there any updates that won't wait 3 weeks? Because normally I would cut us off here, but I also know that we won't meet again for a little while.
When is the next meeting, Rachel?
The week after January 4th.
11th?
The 11th, January 11th.
Yep.
Okay. I will definitely not be on that day because I'm having a thing done. So
Okay.
So I'll have to catch you the week after.
Good luck with your thing.
That is fair.
Thank you. It'll be fine.
Okay.
Merry Christmas to everybody.
Yes,
Happy
Merry
Hanukkah and all that stuff.
I have
Merry
to
holidays.
So thank you. And I do want to say that I have been able to, last week I was in Boulder. I got to talk to the NSF program manager here, and they're very happy with the results. Like everything is, they really like what this group is doing. I'm going to be showing the Grape results at the union session this afternoon. People are very excited about citizen science. And I think this is great. And I think another comment I want to make is, you know, I think, was it Bob said that we're quote unquote the experts? I think we're experts in certain things. You know, if you come to me and you ask me, what do you know about medium scale traveling atmospheric disturbances observed by super darn radars in North America on this particular time, I can tell you more than you probably want to know. And I would consider myself a leading expert in that particular field. I am by no means an expert in all of the, you know, system design and, you know, the engineering and a lot of, and the way we researchers work is we see something, we're like, oh, I didn't expect that. Let's go figure it out. So I think the way, you know, we're working together here and trying to, you know, someone says, oh, I didn't recognize this. The path we're going on is not what I would have expected. And I really think the way we're coming together, looking at it, I think is really productive. So I greatly appreciate that. And I think everyone here at AGU greatly appreciates it too. So thank you.
And once we know it's not my hardware, I'll sleep better.
Yes.
John, I'm gonna send you a request for a node number.
No problem.
If I'm planning to vacation in Alaska again.
Ooh, cool.
And I'll probably put up a Grape at my son's apartment in Anchorage.
That's way cool.
So that's another point on this curve, maybe.
Yeah, no problem.
Okay. I'm going to go ahead and end the recording then.